Welcome to Intro to TypeScript. So by the end of this lesson, I hope that each and every one of you will be able to explain the benefits of static typing and transpile TS to JS. So I'm going to start very simple. And just as a preface, I'm pretty new to this also. So we might be discovering some things together. But I did finally finish my TypeScript book. And I've done some of the exercises in it, so we should be able to at least get started together. So let's talk about this first one. Benefits of static typing. So like broadly speaking, what TypeScript is something that adds static typing to JavaScript. So let's like examine that a little bit. What do we mean by static typing? Think to yourself for a sec. What would not static typing be? Why don't we have static typing already? Keep thinking. Brian O, give it your best shot.
So static typing is sort of putting constrictions on as you're declaring constants, variables, and stuff like that. Currently with JavaScript, you can just declare const equals whatever, and it can be a string, it can be a number, it can be a Boolean, whatever. Static typing means you have to explicitly state what it's going to be. So you'd say const alpha equals number, or is number equals what.
Nice, very good. Anybody else have anything to add to that? Static types, not static types?
Not static types are dynamic, is that right?
Correct.
So they effectively take on the type of whatever you treat them as.
Yes, very good. Opposite of dynamic types. That's what JavaScript uses. JavaScript is a dynamically typed language. So if you use something like a number, it's a number. If you use something like a string, it's a string. And so at the time we write the code, the computer doesn't know what the types are. That's huge. At the time we write the code, the computer doesn't know what the types are. It doesn't know until it runs it. When it runs it, it goes, oh, cool. Looks like you're trying to use like a number here. All right, I can probably make that a number. Cool. Anybody else have anything to add to static types, dynamic types? What else do we know?
So the computer doesn't know for both static and dynamic?
No, computer does know with static.
Okay.
With dynamic types, since the types come from how it's used, we don't know what the types are until we use it. Static types, we are saying up front what the types are, so the computer does know what the types are. Good clarification. What else? What else do we know about static versus dynamic typing?
Well, one thing I'm reading is that static programming language or typed programming languages are the variables need not be defined before they're used, and I'm wondering what the implications are of that.
Sorry, say that one more time.
Basically, it says that the variables need not be defined before they're used.
Yep.
How is that any different from dynamic type?
It's not. Like, that's the same in JavaScript.
Okay, cool.
Right, like any valid JavaScript is okay in TypeScript. As long as,
sorta.
Sort of, right.
Kinda.
I guess until you start mashing them up, right?
Yeah. We'll explore that a little bit when we get into the second objective. When we start, because that's configurable. You can allow JavaScript and then have TypeScript make its best guess. And that's often a step toward migrating something from JavaScript to TypeScript. Anything else we know about static typing versus dynamic typing?
Static typing allows you to catch a lot of errors, compile time versus runtime.
Yes. Catch errors at compile time. So what that means is if you've written logic in your code that's doing something that isn't allowed in the types, before you even are able to run the code, it'll go, flag on the play. That's not allowed. That's a much better time to catch it than when you get the bug report from one of your users, because that's where you find runtime errors. It could even say, by the way, like this is legal code. However, you didn't take into account this case. It can analyze your code since it knows what the types are going to be. It can do a way deeper analysis of what the logic of your app is and give you all kinds of advice on how to make it better.
How does it do that? Is it like in real time? Does it feel? Is it like working with a linter, but like in real time, or how do you get that feedback?
Sure. Great question. So the way that this works is you write a .ts file, and then you run it through a program called TSC, which turns it into a JS file. We haven't broken the laws of physics here. Your browser doesn't understand TypeScript. Your browser still only understands JavaScript. So this is ultimately what we have to have in our code. But this step, which we're going to call transpilation, checks your types and goes, nope, that doesn't work actually. So you get all your warnings and errors and that stuff as part of this process. Now in practice, you also have browser or editor plugins and stuff that will also tell you in real time. But what it's doing under the hood is just running TSC. What else do we know about static types and dynamic types? Let me give you something else. So we know, or we should know, our JS types pretty well. What are the types? And warning, there's some gotchas in here. What are our types in JavaScript? There's 7 of them, I think.
Integers.
Integer is not one of them. Good guess.
Only from playing around in TypeScript earlier, number.
Number. There's only one type of number in JavaScript, and it's number. Every other language in the world has like integer, decimal, float, like all kinds of different number types. JavaScript has number, and next year it'll have one called big int, which is a very large number.
Oh, that's like the number version of like string and text?
Kind of, yeah. Yeah, that's a good comparison.
Null and undefined.
Null and undefined are both types. What else?
Is string a type?
String is a type. What else?
Array?
Array is not a type. Almost.
Object?
That's a tricky one. Object is a type.
Boolean.
Boolean. And one more. It's almost not
symbol?
fair. You probably never used one. What?
Symbol?
Symbol. Very nice. Symbol's a new one. It's something that's guaranteed to be unique. But Kyle, what about arrays? What about functions? What about promises? So all of those are subtypes of object. They're not their own, what we call primitive types.
Yeah, I was looking at some docs, and I guess it's W3 schools.
Mhm.
It maybe the way that they have it structured here on this page is a little misleading, but it does have like array listed as if it's like its own type. It doesn't have it as like a subset of object, but
Prove it.
okay.
So like you can call it, but you do have to specify what's in it still. Maybe that's more
All right,
important.
so if I do some array
Mhm.
like that, and I do type of some array,
Okay, yeah.
Ooh.
What gets confusing is that object is the parent of like anything interesting in JavaScript. So object is what we would call the supertype of function. It's the supertype of array. It's the supertype of promise. It's the supertype of set. There's like all kinds of like badass built-in things in JavaScript. All of them are just different types of objects. So these are built-in types. The powerful thing about static typing is we can also make our own types. We could make a type that's something like traffic light. And a traffic light is something that is either the string red or the string yellow or the string green. We could say that that's a type. Just like Boolean, just like string, just like anything else. We could say that we have a type called dog. And a dog is something that can bark and has an age and has a name. And the power of that is if I know that I'm being given a dog, I know right away, like the computer knows, what things I am and am not allowed to call on that. If I reference a property that's not part of dogs, it knows that it can throw an error. If I try to make it woof, it goes, sorry, dogs don't woof. Dogs bark, did you mean bark? As we're writing the code, it can give us that kind of feedback. That's dope. Ask me some questions.
It's kind of reminding me of like classes and attributes.
Yep.
Is that a bad relationship to make?
Yes. So Ruby is it is a statically typed language. That's what if you'll remember back to mod 1, remember how you used to have to cast things? We might not have used that word with you, but like when you were trying to divide an integer by an integer, it would round off the thing unless you cast one of them as a float. It's because it's a statically typed language. And it goes, all right, well, the result of an integer divided by an integer is an integer. That's type level stuff.
Got it.
On the other hand, an integer divided by a float is always a float. So if you tell it to treat something explicitly as a float, you haven't actually changed the data type. You're changing how it's treated in that instance.
Okay, gotcha.
Yeah, and like classes, objects, all that stuff in Ruby, a class is a type. Awesome. Other questions about static typing?
How elaborate can you make a type, like a custom type? Are there boundaries?
No, you can make them complicated as fuck. And you really like ultimately want to make your types as narrow as possible. You want to like, so something like this, we could have also said that traffic light is string, But then if somebody puts in orange, the types say it's allowed, but it still breaks my app. So I can make these super narrow. I can also say that traffic light additionally defines a change function. And the change function takes in one of these as an argument and returns void. And here's like where this really gets wild. This is where like TypeScript starts getting kind of like draw the rest of the fucking owl. Is, all right, well, what about arrays? You could say that something is an array of what's. So then you start specifying, all right, it's a collection of these types. And then what if it's a collection of promises? All right, well, what do the promises resolve to? So this is why, like, this is a deep rabbit hole you can go down, and you can describe some pretty fucking gnarly ass types. We're not gonna do any of that today, but like that well goes pretty damn deep. The good news is that well also applies to every other type of language.
So I know if you take TypeScript and you compare it with Lodash, but you have to specify the types that are different in Lodash. What are those types that would be different?
So let's take a look at the Lodash docs real quick, and you might get an idea of that. This is maybe the most confusing thing in TypeScript in Lodash, is if we take a look at like their map function, it takes in a collection and an iteratee, which defaults to identity. Those are types. A collection is a type in Lodash. It refers to a particular kind of object and a particular kind of array. And like they have like some shared properties that collectively are referred to as a collection. An iteratee is a function that takes in one argument and there's some constraint on what it returns also. But those are examples of types.
So you could essentially make your own built-in functions and turn them into types.
Correct.
Nice.
Or like if you take an array of Pokemon elements, okay, that can be a type. Both the individual Pokemon object and the array of them, both of those can be types. Like Pokemon and Pokemons. Oh, Jack. The plural of Pokemon is Pokemon. So both our individual and our collection can both be types. And then I can say I want to map over that collection and turn that into a collection of Pokemon DOM elements. And I can specify that as a type. And so you can get narrow enough with these types that you can you can catch a shit ton of errors before your program even runs.
One more thing.
Yeah.
As I'm looking at this, I'm thinking of how you import your SAS libraries. Can you import like function types that you create so that you can use it on everything?
Bingo.
That's awesome.
It is. Cool. So we wanted to be able to explain the benefits of static typing. So we've talked about the error checking. One that we like sort of hinted at, but is a big one, is how much more useful it makes your text editor. So as you have text editor plugins that can analyze this stuff in real time, you get way more red X's and check marks and like all sorts of stuff to tell. And like, if you've ever used Intellisense, that was one of the big selling points of VS Code. Imagine you pull up some object and you type dot, and it tells you every property or method that's allowed on that object, even if it's not in that file. It can tell you that stuff because it knows exactly what the type is. Powerful. So compile time, error checking, better editor. What other benefits do we have?
Kind of makes your code a little easier to read because it's more descriptive.
Yeah. It's also noisier, but you can communicate an awful lot more. That's what we call like expressive code, is code that communicates really well. Your types can communicate a lot. Cool. So those are the 3 benefits of static typing. All right, let's work out some neurons. I want you to Slack, even if it's just what we just talked about, I want you to Slack me in a DM the benefits of static typing, please. Go. All right, send me what you got. Outstanding. Sydney, I loved yours. Would you like to read it?
Sure. The benefit of static typing includes having a clear definition of data types and the ability to catch errors using the TSC and the compile time, as opposed to the runtime. It gives better, clearer error messages in the text editor. This makes the text editor more useful. Even if it's louder, the messages are clearer and you have a more rounded picture of what's going on. You can also custom create data types that you can define and import elsewhere that uses TypeScript, like functions and methods. It's still best to keep them specific and simplified.
Mwah! Beautiful. Very nice, very nice. And so I love your answers. Remember, the text editor piece is huge, and you're going to see that in just a second. So we can say that we're all right on this one. Now, let's get our hands dirty. So what I want you to do is, once you pull down object ball again, you don't have to fork it if you don't want to. I'll put the link in chat. And I want to see if we can, I want to see how far we can get in trying to do some TS with object ball. So first step, let's clone that down. Get this far. And then TypeScript comes in through Node. And so even though we're not doing a Node project, TSC is a Node tool, so we need to make this a Node project. So do that with npm init-y. That's just going to say, hey, we're allowed to solve Node packages here. Really just makes a file, or adds that to the file, I guess. Cool. Then we're going to npm install TypeScript. One of the things that I fucked up when I was prepping for this was the command is called TSC. The npm package is called TypeScript. There's also an npm package called TSC that is not what you're expecting. All right, so we get this far. And now to set something up as a TypeScript project, one file that's like the most important file in any TypeScript project, it's your tsconfig. And we generate one of those with npx, not m, npx tsc -- init. This will tell us that it successfully created a tsconfig.json file.
What's the difference again between npx and npm? It's like one installs locally, another is global or something?
Good guess. npm is our commands for running scripts and installing packages. We're running our scripts. So like, if I wanted to have a test thing here, let's say I'd installed jest. Now I can run npm run test or npm test, and it'll run jest for me. And so this is really handy with, like, imagine this was a Rails app or something. I could have something called setup, and it might be something like Rails DB migrate and Rails DB seed and Rails S. So if I have some complicated S command like that, I can make it a script here in npm. So that's npm. npx is it looks in this .bin folder in your node modules folder and looks for programs there. So connects usually comes in that way. Like the Rails command would have gone here if it was Node. I'm trying to think of other ones. TypeScript. Anything that like also comes with an executable program, it goes in this .bin folder, and npx takes you in there.
Okay, cool, thanks.
Let's take a peek inside that tsconfig.json file. So again, we generated that with npx tsc -- init. Made that file. And so this is just a bunch of boilerplate. Lets us know all the different TypeScript options that we have. I don't want to get into what all of these are, but there's a couple that I'll highlight. Strict that's the goal. If you can get your shit to run in strict, like you don't have type problems. It's usually like a tough place to start. So we can turn that off. And then like all of these are like one by one. These are the parts of strict that we can turn on. Some other things that we got to know is where is this going to get used? So like ES5, it tells us all the options over here. We can say what version of JavaScript. So it can say things like, whoa, 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 whoa. That feature you're trying to use, that's not allowed in ES5, which is where we're going to transpile your JS to. This is like, do you want to use require like you do in Node, or import export like you do in ES 2015? And then this one right here, there's all kinds of like built-in shit we have, right? Like document.create element. If you try doing that in TypeScript, it's going to go, I don't know what a document is. Does it have a function called create element on it? I don't know. So like you can tell it that, oh, by the way, all of the DOM stuff is okay. Or if you're in Node, you do process.env.node.env. It's going to go, I don't know what process is. I don't know what the types are on it. I don't know. Oh, okay. Okay, shh, baby, okay. So you can tell it which things are allowed in your environment. And then these two will let you do, Bennett asked like up top, all right, well, like JavaScript is like valid for TypeScript. It is if we allow it. So, by the way, don't transpile this, just like do your best at checking it. That's an okay place to start as you're taking a JavaScript file to a TypeScript file. And then this is, not only is JavaScript allowed, I want you to check it too. And then like we have some options of like where the compiled files go, like some of that kind of stuff. So I'm going to say for us, let's say that our output directory is dist. Come on, man. And then we need to say where our files are. And so I might have the syntax on this wrong. Bear with me. But I believe it includes, and then it's looking for a directory name, which in object ball is lib, I want to say. Source. Yep. So important things for you to have for this. These guys. We might have to add some others too. Make sure that strict is false. We're allowing JavaScript. We're checking JavaScript. We have an output directory set, and we have an includes directory set. Note that that's an array also. I'll give you a sec to get caught up.
In the includes directory, you don't have to specify that you only want to include the TS files.
No, you can. That's a good question. I don't know if it might want us to do this, but this follows normal like command line globbing thing. So if you only wanted it to do TS files, you could do that. If you wanted to only do JS files, you could do that. I'll bet that will get any file and in any subfolder. But we want it to do JavaScript because we're not changing it to .ts files yet. We just want to see how mad it gets at our JS files. All right. I wonder if that'll run. Let's see. So to TypeScriptify our stuff, npx tsc, let's run it. Hey! Look at all these errors it found. Oh, that's probably include. Let's see if that was it. Oh, it's not a compiler option. That's right. It goes up here. Like I said, I'm new at this too. There we go. So this include should be outside of the compiler options. All right, so it was mad at me about those like built-in types. That tells me that something probably goes in lib. So if I look at tsconfig lib options, what can I throw in here? No. Lib. How about we say ES 2015? That's stuff that you can just assume exists in here. ES 2015. All right, let's see if it's not mad at me anymore. Awesome. So now I'm just getting these things. Ah, and it's console logging. Does Node have a console? It does, but we can also say something like it should have the, let's see, it should have the Node APIs in it. Yeah, what do I say, DOM? Hey, we're down to one error. Cannot find something called game object. All right, we'll deal with that in a sec. So if your TS config looks like mine, you should be down to one error also. Ask me some questions about what you've seen so far. I'll bet, let's try this. Let's narrow this down to just this file, the simple debug one. Could say 01 simple debug. And I'll bet we can get that to compile. npx tsc. Pew pew. So now I have this dist directory here that'll have my transpiled code in it. Very nice. What's in it? Same thing I started with. but it's been checked. I started with this, ran it through TSC. It gave me a thumbs up, made a JavaScript file. Cool. Now let's make it a TypeScript file. So what I want you to do is take that 01 thing in source and change its name to 01 simpledebug.ts. Like that. Now we're going to tell TypeScript that JS isn't allowed anymore. Change that to a TS2. All right. See what happens if we run TSC now. Oops, didn't like something about my JSON. Let's see, what's wrong about this? Holler if you see it. Unexpected token slash. Let's try getting rid of all this.
Where did it say the error was?
I'm going to make it smaller. Said it couldn't parse it because at position 114, fuck, that's hard to find. So that means that like as a string, it's the 114th character. All right. I feel like it has to be one of these. What? Still feel like that looks right. What did I do wrong here? So one of the easiest things to screw up in JSON files is you're not allowed to have trailing commas. They show up red though. I don't see any. Here, I'll say files. Unknown compiler option. Why would you not know that?
Do you still have to say npx TSC?
Boop. I do. Yep. Jesus, come on, man. All right. All right, so cool. We're in business. So now let's take a look at the actual file itself. So for reference, this is what we have in our TS config right now. If I go over to that TS file, hey, weird. It let us do all that stuff, but I don't have the types on here. This is one of the coolest things about TypeScript is it infers the types. If I do something like this, it knows that I'm working with a number. Now, you can also explicitly annotate that. You could say number like that. And that's a type. But to give you a sense of the power of types, it could also be the number 99. Or I could say that it's the number 99 or the number 5 or the number 1. Or one of those could be a string. You can get real specific with what the types are. But it'll do its best to infer otherwise. Let's take a look at an example like, take the debuggers out. What if I did something like write a function? Function is called double. You can say that it takes in some number, which is a number, and you can say that the function also returns a number, and that you're returning number times 2. Oops. So, what a great help. Number only refers to a type. It is being used as a value here. All your errors get so much better. And so now, if I try to do something like double A, argument of type string is not assignable to parameter of type number. It knows that double only takes in numbers. So if I pass in something that isn't a number, I get the red X as I'm writing it. That's fucking awesome. Ask me some questions about that.
What if you don't get the red X while you're typing that?
I'm sorry, what was that?
What if you don't get the red X while you're typing that?
Oh, you might need a the VS Code TypeScript plugin, which is has kind of a silly name, I thought. Did any of you have to set up anything for it in VS Code? TypeScript is a Microsoft product, as is VS Code. So it should have pretty robust stuff kind of built in.
I didn't have to install anything, but I also went to the first TypeScript class you did like a mod or two ago. Do you know if you did anything differently?
I think so.
I mean, if you have just the regular ESLint plugin already, mine is detects TypeScript. So
there you go. So yeah, like, and that's just going to the plugins or whatever, installing the ESLint one.
I would just type in install -g TypeScript.
Oh, it's not going to hurt you to have it globally installed, which would be npm install -g TypeScript. Oh, it's mad because I already have a TSC. Yeah, if you have that installed globally, maybe that's what you have to do.
Gives me lots of errors.
All right, we can touch base after this music.
Yeah.
Cool. So as you're writing code, you can just do colon and then whatever the thing is. It's pretty neat. And like I said, you can make it pretty narrow too. You could say like, oh, this is a weird thing that only takes in the number 30. And now it's mad at me. And now it's not mad at me. Sick. I'm trying to think if there's other stuff that you need to know to get started with this. I'm going to show you a syntax real quick that you'll run across really early, and it'll probably freak you out a little bit. Oh, two. One is, let's say we were taking in some numbers like that. You just put the little like array brackets after it to tell it that it's a number. It's an array of numbers. And now, if we wanted to like map over each of those, now we're also going to bring back an array of numbers. So we might say is like some numbers dot map, and we'll take in some number and return some number times 2. So if you want to make an array of something, you say the thing that's in the array, whatever type that is, and then these square brackets. The other one, and this is like the next level of TypeScript, is a thing called generics, which is like, I don't know what the type is going to be ahead of time. But what you can say is like, whatever type this is going to have, maybe it's not numbers, but I can say that it's an array of those things, and it's going to bring back whatever that same type is. Do something like that. That's called a generic. And that's enough to get you started with TypeScript. Hit me with some questions.
It's only catching those errors when you're in a TS file, right? Like if you were writing in JavaScript, it wouldn't catch all that?
So it tries, but the problem with JavaScript is since it's dynamically typed, what it does most of the time is it goes with the broadest type possible, which is usually any. And any is always allowed, but any is essentially, I'm not typing this. And so if it'll give it a shot with JavaScript, but it infers most things as any, which is you may as well not have anything.
So is that the opposite of the sum type in a way?
The sum type, what do you mean?
The parameter that you put in if you don't know the type yet, the generic.
Oh, the generic type. No, I wouldn't say there's a relationship there, but if that is like as specific as we could possibly get. There's only one legal value for it. This would be the opposite of that, where literally anything, a Boolean, a complex object, a string, null, undefined, any of those are allowed.
Oh, so that's like normal JavaScript variables.
Exactly.
Okay.
And that's even like a step sometimes that people will take while they're going from JavaScript to TypeScript, is they'll say, all right, I'm just going to throw any as the type on all of these, and then I'll work to get rid of all my any's. That's even an option in the compile thing, is like whether or not you allow any's. If you have strict on, strict won't allow you to have an any type. Another thing that you'll see is you can declare types the same way that you can declare variables. So you do something like, instead of const, you just say type. And you could say something like, this is dumb refactor me equals any. And now we can just replace that every place we're using that. And that's like, it's like a to-do kind of. But like, that's a pretty common step getting toward TypeScript. Other TS questions?
Can you discuss a little bit about using definitely typed to get like React packages, their types and stuff like that?
Totally. So the idea with definitely typed is like, Lodash is a good example. How do I know what all these functions in Lodash return? I didn't write them, and they didn't ship me TypeScript. They shipped me JavaScript. So there's a community. It's almost like a GitHub or an NPM style thing that's just the types for popular libraries. So let's say I wanted to bring in types or Lodash. I can install Lodash, and I can install @types/Lodash. And this is community maintained, so there's no like guarantees that these are accurate at all. But especially for the big stuff, they're pretty good. And it's just @types/whatever the name of the package is. So that not only gives us Lodash, but it also gives us the types for Lodash. So now I can do something like if I import map from Lodash FP, I got the squiggly to go away. And if I do something like map 3, it goes, Lodash FP's map doesn't take in a number, it takes in a function, which takes in a number. And then it's going to expect you to assign that to something. Let's see, left-hand side of an arithmetic type must be any. Oh, it needs a type for this. So that's going to be number array, maybe. Inside of an arithmetic operation. Mad about this. Let's see.
Does it need the squiggly braces?
It does. It shouldn't need them. Oops, that's just a syntax problem. Let's see, return. Okay, so I have this function that's taking in a number and returning, x. Okay. Cannot find name x. It's right there. Maybe it needs to be in these. Oh, that's happier. Type number. Ah, see, it even caught an error. That's absolutely not how it works. It has to be an array of things. Cool. So now I was able to use this Lodash functional programming thing that Lodash defines, but I pulled in its types from definitely typed. And the way that these things generally work, actually, I won't get into that, but it's not only pulling in this function, it's also pulling in the types for those functions. Questions? Cool. There's a little bit of TS. Happy hunting.
Thank you.